All right. Waiting for it to go live. All right, let's see. We have solved the system by substitution. Let me move this over just a little bit so I can see it better. Oh, something went wrong. Hold on. Hopefully it's not that I'm not connected to the internet anymore. Let me try to load it again. All right, there we go. Solve the system by substitution. So here's what substitution means. You take one of the equations, solve it for one of the variables, which this is already solved for a variable, right? And then you plug it in to the other one so that you no longer have two equations with two variables. Now you have one equation with one variable. So I explained it, now I'll do it. I'm gonna take this and plug it in here. I'm even gonna color code it so you can see what I'm doing. I'm gonna write the equation out, and instead of X, I'm gonna put a big bracket in there. And now I'm plugging in what X was, which was 3y plus 5. And now notice I don't have two equations with two variables. I have one equation with one variable. And to solve it then, I would distribute, add like terms, get y by itself, and be done with it. So I'll do that real quick. Distribute, this is 21y, plus distribute there, it's 35, plus 5y equals 9. So add like terms, that's 27, whoops, not 27, 26y plus 35 equals 9. Subtract 35 from both sides. You get negative 26. Well, how convenient. 26y equals negative 26, which means y equals negative 1, divide both sides. So y equals negative 1. Now I'm going to plug that back in to that second equation, or the first, but the second's easier, to find out what x equals. So x equals 3 times y plus 5. Plug negative 1 back in, and I see that x equals 2. So my point is 2 comma negative 1. That's my solution. 2 comma negative 1. That's solving by substitution. Let's try another one. A student has some $1 and $5 bills in his wallet. He has a total of 14 bills. All right, so we're going to call the $1 bills. We're going to say X for the number of $1 bills, and we're going to say Y for the number of $2 bills. So X equals the number of ones, and Y equals the number of twos. I'm sorry, fives, $5 bills. So what do we know about it? Well, it says that there's a total of 14 bills. So that means X plus Y equals 14. The number of $1 bills plus the number of $2 bills equals 14. And it also says that they are worth $34. So their worth is 34. Well, their worth is 1 times the number of $1 bills plus 5 times the number of $5 bills. That's their worth. You see how I came up with that?
Yeah.
So I have a system of equations. Now I can solve this. I don't need this one here anymore. I can solve this either with substitution or graphing or elimination, called linear combinations, or all kinds of matrices even, which I haven't taught you yet, you haven't learned yet. But I'm going to choose to use, do you know what method I'm going to use to solve this?
Substitution.
Nope.
Elimination.
Yeah, I'm going to eliminate the x's. So I'm going to multiply everything up there by -1. And now I'm going to add them straight down. And when I add them down, the x's are gone. The y's become 4y. And over here it equals 20. So y equals 5. So if I have 5 $5 bills, plug it back in to the blue equation up there. X plus 5 equals 14. Then I have 9 $1 bills. And if I do the math on it, if I check it, 9 plus 25, hey, that's 34. That worked out. So I had 9 $1 bills and $5 bills. Good?
Mhm.
Solve by the elimination method. All right. Well, the elimination method is what I just showed you. And fortunately, this is already set up because look, I can just add them straight down. But what's going to happen when I do that? I eliminate both of them and I get 0 equals 12. What? 0
doesn't-
equals 12. That never happens. Since that never happens, this has no solution, which means they are parallel lines. Those two lines, if you were to graph them, you would see that those are two parallel lines.
Mhm.
They're never going to intersect, so there is no solution for that. Good.
So is that with any, so if both the variables cancel out, that means
I'm glad you asked, because no, that's not always. If both the variables cancel out and it's not a true equation, then it's no solution. But if it is a true equation like
then
this, for example,
many, right?
yes, if it was that equation, now everything is going to cancel out and you're going to get 0 equals 0
Yeah.
when you add those together. And how is that true? Does 0 equal 0?
Mm-hmm.
Yes, it's true all the time. So it's true for all x and y, which means there's an infinite number of solutions. Specifically, all points on the line.
Yeah.
That doesn't mean that every point is a solution, because some points might not be on those lines. But this line, that's the first one, and that's the second one. I just drew it right over the top of it.
Mm-hmm.
They're the same line. So any point that's on that line is going to be a solution. If there's a point outside the line, that won't be a solution. But any point on the line is going to solve both equations. So all of those points are solutions.
Yeah.
This says graph the solution set of the system. All right, so this is what is this called again? Linear programming, do they call it? Or actually, this is just a system. They're not telling you to maximize or minimize anything. All right, so remember the trick with these problems. The trick with these is I'm supposed to plug in, use the cover up method. Remember that cover up method? So plug in 0 for x, and you see that y equals -6. So -0, -6 is 1 point. Now plug in 0 for y and solve for x. So x equals -3. If you can do that in your head, divide both sides by -2, you get -3. So that's that one. And now connect them. And it's a solid line because there's an equal to underneath it.
Yeah.
Now let's see which way I should shade that. Does 0, 0 work in this equation? If I plug 0 into this, does that work?
No.
No, it doesn't. So it's not this way. It's this way. Do you get how I did that?
Yeah.
Now let's graph this. So sorry, let me color code that. Now let's graph this line right here. Y is greater than or equal to -4. So -4, y is greater than or equal to means that x can be anything, but y has to be greater than or equal to -4. So that's y equals -4. So anything above it is greater than or equal to it. And this line here, x is greater than or equal to -8. Well, x is equal to -8 is a vertical line. So x is greater than or equal to it means that y can be whatever it wants to be, but x has to be greater than or equal to -8, which means it goes this way.
Yeah.
So now we can take out our big eraser and we can erase everything that is not overlapping with all three colors. So there's my solution. You don't really have to erase it, but I like to do that so that it's not hard to see. What's that?
It makes it neater and easier to understand.
Yeah, and plus it's fun. It's fun to do with the iPad.
That is.
Are we good? Good with that one?
Mm-hmm.
Solve the system of equations. Ooh, now we've got a 3x3 equation. All right, so this is a little bit trickier.
There's so much work.
So when you have a 3x3, there's a shortcut, but I'm not going to spoil it. It's fun for the teacher to teach it to you. I'm going to go ahead and write them all out. 8a minus 2c. Notice how I leave a little bit of extra space there.
Yeah.
It's a good thing to do. And then the last one is 6b minus 2c equals negative 32. So the key with this is you want to find out, you want to do kind of a piecewise thing. You're going to combine these two right here and eliminate something, and combine these two right here, or a different two, and eliminate the same variable.
Yeah.
So you want to eliminate the same variable from both of them, usually. This one looks a little bit tricky to do that too, though. See, if I eliminate the, yeah, no, I can do that. Yeah, it can be done. So let's eliminate. Oh, you know what we really only have to do? Actually, now that I think about it, if we eliminate the a on this, we can just use this equation because it doesn't have an a in it anyway.
There you go.
So we're going to combine those two top equations and eliminate the a. So let's multiply that top one by -2, right?
Yeah.
So that's negative 8a minus 14b equals 48. And now add those together. The a's cancel out. The b's are negative 14b. There's negative 2c, and that equals 48. So there's that equation. Let's write this other equation back underneath it so it's easy to see. And actually, while we do it, let's multiply it by -1. Do you know why I'm doing that?
To reverse it. Wait. Where did you get the 14b, 2c, negative 14b?
I combined this blue one and this one right here. So this was gone.
I thought you did that with the bottom one, and I was like, wait, what?
No, I did that because I realized, oh, let's eliminate the a's so that I can just use this equation as my other one. And now I can, and I also multiplied that by -1 over there so that I can just add them together and the c's will be eliminated. So now I've got -20b equals 80. Yeah, 80. Which means b equals -4.
Yeah.
Now, if b equals -4, which one of those equations should I plug it into up at the top?
The top one or the bottom one?
Yeah, either one, because if I plug it into this one, I can solve for a. If I plug it into this one, I can solve for c. So we're going to actually do it into both of them. So let's plug that in. So 4a plus 7b, which is -4, equals -24. Let's solve for a. So 4a equals -28. I'm sorry, not equals, plus. Let's start over. 4a minus 28, excuse me, equals -24. Add 28 to both sides. You get 4, so a equals 1. And now let's plug in again. Now you can actually plug in a into there if you want, if that's easier, or you can plug b into there. Either way, you should get the same answer. If you don't, something's wrong with what we did, but I'm pretty sure we will. Let's plug it into the second one. Let's plug a into the second one. A times 1 minus 2c equals 0. So -2c equals -8, which means c equals +4. Now let's just plug it in and make sure that works. If I plug in +4 here and -4 here, I should get -32. Let's see if that happens. This is -24. This is -8. which equals negative 32. Perfect. So that worked. You see, you can always check your solutions, right? You can do the same thing with this. You can plug in 1 and you can plug in 4 and it should equal 0, and it will. And you can plug in 1 and you can plug in negative 4 and it should equal negative 24, and it does. Good?
Yeah.
So this one looks a little bit more complicated, but that's okay. I'm not afraid of it. Let's just do that same thing. Now this is going to be harder because I don't have anything eliminated already. Like on the last one, there was a lot of variables missing. So
Yeah.
for this one, we're going to have to do that thing where we go here and here first and then eliminate the same thing in this one right here or something. So what would be an easy variable to eliminate in both? There's not really an easy one. So let's just pick one. Let's get rid of the z. Okay. The reason I say there's not an easy one is because I'm looking at all of these things. Are these multiples of each other?
No.
Nope. Are these multiples of each other? All three of them? Nope. Are these all multiples of each other? Nope. So we're going to have to do a little bit of work. Not a lot, but a little bit. So to eliminate z, we're going to eliminate z. Here, I'm going to write it like this. Okay, that was ugly. Z.
There you go.
We're eliminating it. Okay?
Yeah.
So to eliminate it, I'm going to multiply this one first by, I'm going to show a little work here. I'm going to multiply this by 3. So that means I have 15x minus 3y plus 3z equals negative 24. And you have to be careful and make sure you're doing everything correctly. I'm going to keep this one as is, but I'm going to write it here. So this is 3x plus 2y minus 3z. Hey, because those are going to subtract, right? Equals there. And then I'm going to go ahead and add these things together and see what I get. I'm going to write it over here, though. When I combine those together, what do I get?
Well, the z's cancel.
Good. So I get
So
18x.
18x minus y, yeah.
Equals negative 31. Did I do that right?
What was it? Negative 24 plus. Yep.
All right, now we're going to get these ones here. Let's multiply this equation. We're going to multiply this equation by positive 2. And we're going to multiply this equation by negative or by positive 3. You understand why? Because I'm trying to eliminate the z.
Yeah.
You follow? So let's write that out. So multiplying it by 2, the middle equation by 2, it's going to be 6x plus 4y minus 6z equals negative 14. Don't forget to multiply that right side by 2 also.
Yeah.
Multiplying that other one by 3, I'm going to get 3x minus 9y plus 6z, yay, equals 21. Now I'm going to combine those together. And what do I get when I combine those together? The z's go away. What are the x's?
X, 9y.
I got 9x.
Minus 5y.
Equals? 7. Good job. Now,
yeah, 7.
you see these? Hey, look at that. Now I can eliminate which one, the x or the y?
I was gonna say x.
Okay. So how do I eliminate the x? It doesn't really matter. No, I think x is a better choice.
Yeah. X
so what do I have to do to eliminate the x?
Multiply by negative 2.
That's right. And I get negative 18x plus 10y, don't forget about the signs, equals negative 14. And now I can just say, ignore that. And now I'm going to add these two together, right? I'm going to add down, and the x's go away. Good. The y's are a 9y, and the z and the constant on the right is a, wait for it, negative 45, which is a multiple of 9. So what does y equal?
Y equals 5.
Negative 5. Good job. Y equals negative 5. Don't forget that. Make sure you're careful, because if you make one tiny mistake, the whole thing is ruined. That's the thing that's so frustrating about this. All right. Now I have the y. How do I go back and find the z and the x? Take it.
Plug that in.
Plug it in. Either one. Doesn't matter. I'll plug it into the top one. Oh, that's still x. I'm trying to find x minus y, which is negative 5, equals negative 31. So 18x plus 5 equals negative 31. So 18x equals negative 36. Oh, I love it when it works out. Negative 2. And how do I find z now? Take that and plug it into one of these. Doesn't matter which one. Let's use the top one. The top one, I'll use black down here. So it's 5x minus y plus z equals negative 8. What am I plugging in for x? Negative 2. What am I plugging in for y? Negative 5. Negative 10 plus 5 plus z equals negative 8. That means negative 5 plus z equals negative 8. That means z equals negative 3. There's my z. Let's see if it works. Let's plug it into the bottom equation and see if it works. If I plug in negative 2 and negative 5 and negative 3, I should get 7 when I do the math. So that's negative 2 plus 15 minus 6 equals 7. Is that true? It sure is. It's true. And therefore I know it's probably right. I could plug it into this middle one too to make sure, but I'm pretty sure it's right.
Math Excel disagrees.
Well, Math Excel is wrong. Did you type in the x, y, and z correctly? Negative 2, negative 5, negative 3?
No, I didn't.
Mm-hmm.
Oh my god. There we go.